The throughput graph shows throughput for each technology, and let me swap it with the timeline so it's a little easier to see. Each technology is color-coded as it is in the timeline, with 802.11 being orange, classic blue, and low energy green. Throughput is shown in bits per second. So here we have 802.11, low energy, and classic. We can show payload throughput, packet throughput, or both, in which case we get both sets of lines drawn. Each data point has a tooltip, which shows the throughput, how the throughput is calculated, and the packet range involved. The viewport defines the time range used by the timeline. The packet range that it covers are shown above it. These are the same packet numbers that are shown above the timeline. The packet numbers for the entire capture are also shown. And in the footer, we see the total duration of the capture and the beginning and ending timestamps. The header shows the duration per data point and the total number of data points per plot. And the way it works is that initially each data point is 1/10 of a second. When we get up to 300 data points, the duration is doubled and the number of data points is halved. So it would go from 300 data points to 150 data points, and the duration would go from 1/10 of a second to 2/10 of a second. That doubling and halving repeats every time the number of data points reaches 300. So the duration will go from 1/10 to 2/10 to 4/10 to 8/10 to 1.6 seconds, and so on. Now eventually the amount of time covered by each data point can get pretty large. At this point, at 1.6 seconds, it's already pretty large. And it would be nice to see what's happening inside each of those data points. So there's also a zoomed throughput graph, which lets you zoom into the time range covered by the viewport. And as you move the viewport, both the timeline and the zoom throughput graph move with it. The packet range above the viewport, which is replicated above the timeline, is also replicated above the zoomed throughput graph. You can also set the time range of the zoom throughput graph by zooming to a single data point in the session throughput graph. So if you right-click it and go zoom to throughput graph data point, you now see the zoom of that single data point. So this is the highest 802.11 throughput we have in the session throughput graph. Most of that activity is happening right here. And you can see what's happening at each dot with the tooltips. Now you'll note that as you scroll, the y-axis values in the zoom throughput graph are changing. That's because the highest data point in each technology is snapped to the top of the graph. Now on the one hand, that makes it easy to see the data that you have because it fills the graph. But on the other hand, it makes it impossible pretty much to compare different windows. So in that case, you can freeze the y-axes, and then they don't change as you scroll. So now you'll see in this case that some of them are running off the top, but that's okay, that's what we want. That makes it possible to do a relative comparison between the different windows. The dots that are drawn, they can help with visibility, but they're also very important for cases where data points are overlapping. Because when data points overlap completely, you only see the top one, and the others are completely obscured. So let me get to a point where that's true. Right about there. So here we have 3 data points that are overlapping. Without the dots, you would never know it. You can see the tooltip for each dot by getting right on the color for that dot.